Bienvenidos, Hushamdid, and welcome UMGC learners from the CMIT-455 Section 6380 course for the spring 2021 semester. This is the Cisco Networking Academy's CCNP ENCOR version 8 course curriculum, and in this packet tracer activity, we're going to be taking a look at packet tracer 26.2.4, where we're going to be configuring secure passwords and SSH. Now, this is an activity that is going to provide you with the majority of the commands you need to run, and we're going to add some value here by talking about different algorithms that you can use when you're configuring your passwords. And so we'll get to those in turn. And so we've got, again, a very simple topology here that we're working with. Router A, PCA, and switch 1. Everything is in VLAN 1. So let's go ahead and take a look at the instructions here and let's dive in. So we're going to configure IP addressing on PCA according to the addressing table. So let's go ahead and pull our PC up. You can see we have a console cable connection here between the PC and the router. So we go to the config tab. We go to the desktop tab and we go to the IP configuration, and let's get our IP address in here for PCA 172.16.1.10. Now you'll notice that it puts in that default class B classful dotted decimal subnet mask. Now this is incorrect because we have subnetted it down to a /24. In other words, we borrowed all 8 bits in the third octet to be network bits. And then our default gateway value here is going to be 172.16.1.1. And there is no DNS server, and you can see we're already at 9%. So let me go ahead and close that down. So we configured the IP addressing on PCA. Now let's console into router A from the terminal. In fact, I'm going to give us some more room with which to work here because a lot of the configuration work will be off the PC. So we come to the terminal box. All of these settings are the defaults, and those are fine. And you can see here I am logged into the router. So let's go from user exec with the enable command into privilege exec. And we're going to get into global config here. Now, on router A, it's going to be interface gigabit Ethernet 00. I'm going to say no shut. And as you can see, it'll bring the interface up. If you'd like to, we have some configuration work to do, but spanning tree, you're going to wait about 30, 45 seconds here until this turns into the green pyramid on the device. So I'm in gigabit Ethernet 00, and let's go ahead and say IP address 172.16.1.1. That is our default gateway address, and it is also a /24. Now, we configured the host name as well, so let's go ahead and say host name RTA actually is what they're calling it here. I was saying router 1, but RTA. And we enabled the interface, we configured things. So now we're going to encrypt all plain text passwords, right? So we're going to say service password encryption. We're going to set the minimum password length to 10. Now, there is no equivalent command on Cisco switches. I remember when I first saw this command years ago for routers, that I immediately decided that I would try to apply it to switches. And it just doesn't work. It's just not there for whatever reason. And so that command is security. Oops, and there's another command that's pretty close to that. So security password min length. And here you can see we can set the minimum length of all user and enable passwords between 0 and 16 characters, right? And so the minimum length we're going to set to 10. So we're going to have at least 10 characters in any password that we can create. Now, it wants us to disable DNS lookup, so no IP domain lookup. And so we got a few points for that. And let's see, set the domain name, right? So when we're setting, and again, this kind of ties in with project number 3, right? So if you're tracking along with the project, this ties in with the project number 3, because you had to do this, or it was optional for you to do this on the switches after, in the headquarters office, after you were shown how to do this on the router 1 in the HQ office. And so I can't say crypto key generate RSA. I have to have the domain name defined first, right? Because the domain name is used as part of this key creation. And so let's go ahead and say domain name, and we're going to do all caps ccna.com. Now, what's interesting is this is actually another one of those activities out of the CCNA security course. And you can see here, you kind of got the remnants of CCNA in that domain name that we just created. So now we're going to create a username, right? And here's where it gets interesting. So we're going to say user, and it says any user. So I'm just going to say admin. Now, we've got a couple choices here, right? I can say password, which is going to give me a type 7 password. I can say secret, which is going to give me a type 5 password. You can even set the privilege level. By default, if I don't set the privilege level, by default, the privilege level will be 1. So we're going to say secret, and this is going to give us a type 5. And here's where we're going to do a little segue in just a second to try to add some value to the activity. And we'll just say, so here's what I'll do. Watch. If I do ABC123, let's see if it takes that. It doesn't. So there's confirmation that it has to be at least 10 characters. So we have 6 characters. What about ABCD1234? Well, that's only 8. Still too short, right? So we'll say ABCDE1234 5. And that meets that minimum requirement, right? So on routers, if you're using local database authentication for your users, it's a great idea to set this up. Now, the last activity of this course, we're going to be talking about the new model of authentication, authorization, and accounting, which is AAA. And we would say AAA new model. The way we're doing it here, you can refer to this as the old model, which is we've got this local user database on router A that only router A knows about, that is not stored in some central location that other routers are able to use these router names when accessing devices, right? So this is considered the old model. Now, a brief segue here because it is definitely due, and we talk about this a lot in other courses where we're looking at using this username, admin, and then secret, right? Now that gives us a type 5 password. However, if you were to reference back to the CCNA Security 2.0 documentation, and it's right here, right? And it's interesting because this was in one of the labs out of the CCNA Security course 2.0, version 2.0, which is no more, right? CCNA Security is no more. You have this command here, and this is the best practice. However, Packet Tracer doesn't support this functionality, which is why we don't see it here. Now, in an in-class scenario, this is what you would want to do. This would be considered the best practice when configuring local user accounts. So we would go into global config. I would say enable, and we could do it for privilege exec, right? I can do it for a user as well as I can do it for the privilege exec password. And it's this algorithm type, right? And I'm on an older 2811 router here running 15.1 code. So this is, definitely an older router, and it's still supported. And you can see the different algorithms that we could use as our hashing algorithms here. So we have MD5, right? And MD5 is not recommended for use unless you've got no other option, right? Especially when you have script and SHA-256. So script is by far the most secure of all of the hashing algorithms. And you can see here that we simply put in ABC123, right? And so that's what that would look like as the command for the enable password. Now, if I was to say something like username admin username admin and do a question mark, you'll see algorithm type is one of the choices again. So for users, you can set this up as well. So algorithm type And let's go ahead and say SHA-256 and secret and the unencrypted clear text. So ABC123. Oops, sorry, ABC123. Right, so now let's compare the two strings. So I'm going to say do show run and include, let's see, secret. And that should trim it down for us to where we see, yeah, and so you can clearly see here for the username admin, take a look at the length of that hash, right? And the same is true here of the type 9. So type 9 is script. Type 8 is SHA-256. Now, one of the major advantages of the script hashing algorithm is that if you try to brute force attack it, the operations become more and more expensive from a compute perspective, meaning, you know, you try one password and it fails, and you try another and it fails, and another and it fails. Each time you do that, it gets more and more expensive in terms of your compute resources, right? And so it gets to the point where it's kind of useless trying to do a brute force attack. So again, type 9 is a best practice, all things being equal, right? You can't go wrong with the type 8 or the type 9 because they are both exponentially better than what a type 5 would be. And so typically, you know, the rule of thumb that I explain to learners is in the hash, if you simply take a look at the length of the hash, that's going to give you an idea as to how secure it is or not. So let's do this. We'll say username admin1, password ABC123, and then we'll say service password encryption so that it does the little Vignere cipher thing on it. And then let's go ahead and say username admin2 and algorithm type, and we'll use MD5, secret, and ABC123. So they all have the same password, but take a look at the difference, and then we'll have to get the, and actually we could do, what do I want for, where's the, was admin1. So that's what we want to see. So when we take a look at this, right, you can clearly see that a type 7 password, this is very easy to hack. In fact, there's a million websites where I can simply copy that password, come out here to Firefox, and let's go ahead and go to crack type 7 password. We paste the password in. I'll just pick the first one out of the million sites that are available. Copy that, or I'm sorry, copy the Vignere cipher there. And that's how easy it is to crack your type 7 password. It is literally that simple, right? And again, Cisco's been clear, the type 7 passwords are not to defend against the wiliest of hackers. It's for your shoulder surfer, because that's a lot harder to remember than ABC123, right? But when you look at that and you compare it to the type 5, you would say, wow, the type 5, I mean, this looks way more complex. And it is. It's a one-way hash. And this is probably not something you're going to be able to type into a website and get an answer back that fast, right? So you look at the type 5 and you're like, wow, way better than a type 7. But then look at the type 8 compared to the type 5, right? I mean, we can clearly see here that this is a much more complex hash. And then the same can be said of the type 9 when compared to the type 8, right? So these two are probably right around the exact same length, if not exact. They're very close to being exact. I don't have them shuffled over properly here. But as you can see, all things being equal, script is going to be your best choice. SHA-256, option number 2. MD5, if you have to, option 3. And then type 7, if you must, right? So keep that in mind, that those are actually the hashing algorithms you're going to want to be using. Now, I understand why they've got the activity set up the way they do here, right? Packet Tracer 1 doesn't support SHA-256 and script. And 2, it's more as an activity to kind of get you to thinking, okay, well, this is how we would set things up and secure it initially. And yes, I mean, this is, again, a valid configuration, but it could be improved. All right, so we left off there. Now that we've got the domain name, I can say crypto key generate RSA, and here they have you simply hit enter. Now, you can see I could say something like general keys, and then do the modulus, and then put the value in. But they simply want us to name the keys. Let's pull it back here. They want us to provide crypto key generate RSA, and they want us to put in, and so you can see the name is going to be rta.ccna.com. So there's your domain name and the host name working together for the name of the keys. That's the role that those two components play. Again, there's the host name, there's the domain name, and that will be the default name for the keys that we're creating. And so we're going to set this to 1024. And again, you can go up to, I believe it was 2048 or 4096. And let me show you how you would do that here on a real Cisco router. And again, the more bits you choose, even on, I've done this on Cisco 9300s, 9200s, the Catalyst switches. I mean, it is an intensive operation when you're doing, let's go ahead and say crypto key. And in fact, I don't think I've got my IP domain name. We'll just say ccna.com. And so if I was to say crypto key generate RSA, you can see we get a few more options here, right? So let me go ahead and just drop modulus in. And again, this is not how Packet Tracer presented it to us. It didn't give us the modulus option. It gave us the general keys option, but you can cut to the chase and say modulus, and I can do 4096. So watch what happens when I do 4096, and you can see I'm hitting the return key. We are not getting the prompt back, right? Because it is now generating an RS key that is 4,096 bits in length. On a 2800 series, that is going to take, that could take up to 60 seconds. So, we'll float back over here, but I just wanted to show you that, that there is a cost when you do that. And you obviously, you want to go with what is going to be most secure for your context, for your use case. All right, so we created the RSA keys, and now we can go ahead and start to float down. And let me get the switch IP. Is it 1.2? Yes, it's 1.2. All right, so now we can kind of get down here. We're going to block anyone for 3 minutes who fails to log in after 4 attempts. And again, they give us the command, right? So log in, block for 180 seconds. So block for 3 minutes anyone that attempts to log in, and you can see we can set it to, you can be pretty gracious with the number of failed attempts. Here we're going to be doing 4. And if they fail within 4 attempts within 2 minutes, 120 seconds, we're going to block them for 3 minutes, right? Again, these are all locally defined things that are going to happen only on router A, right? This is only on router A. So now we're going to configure the VTY lines for SSH. So I'm going to say line VTY 0 through 4. Now, if I say do show run and pipe it to section line VTY, you can see that there's an exec timeout command there. And I'm going to talk about that as well because, and actually they have it up here for us to do, but it's good to talk about it as well. So actually there are 15 VTY lines, line VTY 0 through 15. We want to make sure we touch all of these VTY lines here. And I'm sorry, actually, they actually want us to only do 0 through 4. Sorry about that. All right, so how do we set it so that the transport input is SSH, right? And what this means is we are not accepting Telnet. We are only accepting SSH remote connections into the virtual terminal lines, the VTY lines. Now remember, we also need login is there, and here it actually says no login, but we need login local. And what that means is log in using the local user database, right? Remember the username we created, admin, with the password ABCDE12345. That's what login local means. It means use those local credentials in the local user database in order to connect to the router. Now, the exec timeout command, and this is one if you're going to be working in any kind of a government environment, I can guarantee you will be configuring this, right? So what this does is it says if a user is idle on a so I SSH into the router, right? And then a buddy comes over and says, hey, check out this Instagram post. And so then I run off and we go look at this Instagram post, and I'm away and I'm idle for a number of minutes. And here they're saying 6, and you can even be so granular as to put the seconds. So I could say 6 minutes and 30 seconds. So if you haven't hit a keystroke in 6 minutes and 30 seconds, your SSH section into the VTY lines that you're remotely connected to is no longer going to work. Or I should say no longer going to work. It's going to terminate, right? And then you can have to log back in. So poor choice of words there. It's still going to continue to work. You just have to re-log in, right? So it's going to log you out. So we're going to simply say exec timeout 6, right? So now it wants us to access the prompt on the PCA desktop to establish an SSH connection. Well, before we do that, let's just go ahead, good measure, and let me save. And actually, do they have us? Or are they going to ask for that later on? Let me double check here and make sure. Yeah, so they're going to have us do that later on. So I will wait to save the config because I don't want this activity to blow up if I run the write mem too early. All right, so now let's close out the terminal window on the PC. Let's pull up the command prompt on the PC. And let's say SSH, and remember, that is a -L. It is not a 1. And the most common thing is that users think it's a 1, right? Or new users and new learners to the CCNA. So 192.168.1.1, because remember, this interface is up now. We've got the router configured to accept remote connections, and we've got connectivity through the switch. Now, we haven't done anything with the switch, but we will here shortly. So I say SSH -L admin 192.168.1.1, and it says connection timed out or host not responding. Well, let's check and see 168.1.1. Destination is, oh, sorry. I was thinking 192. It's 172. All right, 172.16.1.1. You can see I'm in that 192 mode. So SSH -L admin 172.16.1.1. Much better outcome here. A, B, C, D, E, 1, 2, 3, 4, 5. And there I am on router A. So now let's do some basic security configuration on our switch. So let's pull the switch CLI up here. Let's give ourselves a little bit more room with which to work, and let's hit the CLI. So we're going to go from user exec with the enable command to privilege exec, and we're going to configure with corresponding security measures. Okay, so we're going to click on switch one CLI tab. So configure the host name, making sure we're getting everything done here. That way we don't end up with a less than 100%. So we're going to say host name, switch 1, and configure the IP addressing on VLAN 1. So here's where we're going into the switched virtual interface, right? So interface VLAN 1. It is a virtual layer 3 interface that we're able to create on a layer 2 switch. Typically, and most popularly on a layer 2 device, this SVI is used to manage the device or to give the device connectivity to some VLAN that is set up. So interface VLAN 1, we're going to say packet tracer, we're going to be saying no shut, right? If I was to come over to a real Cisco device and a lot of, well, sorry, I don't actually have a switch up and operational right now, but on a real Cisco device, typically if you have something that's up and operational in that VLAN, it's going to come up auto-magically for you, but that's okay. So we're going to say IP address 172.16.1.2, and we know that this is a /24. Now we're going to configure the default gateway address. Remember, this is not the address that PCA is using to route traffic, right? This is switch 1. Think of switch 1 as a PC right now. If switch 1 is trying to connect to something off a network that it knows about to some other external network that it is not directly connected to, just like PCA needs a default gateway, so does switch 1. And so that's what we're doing here with the IP default gateway. Oops, sorry, let's get an interface config mode. With the IP default gateway command, 16.1.1, for traffic generated by the switch, not transit traffic passing through the switch. Transit traffic is PCA's traffic that's coming through switch 1 to get to router A. That is transiting switch 1. The IP default gateway statement is for the management plane traffic, right? Or I should say control plane traffic, right? Where we are generating pings from switch 1, or we are generating an SSH session from switch 1, or a trace route from switch 1. That is the default gateway value that is going to be used by that traffic, not the traffic passing through, transiting the switch. And so we'll drop in the IP default gateway. And let's go ahead and actually we're already at the bottom of the activity here. So disable all unused switch ports, right? And not only is it a good practice, it's an even better practice to create a VLAN that is shut down and to put those ports that are unused into that VLAN, right? So let's go out a little bit outside this activity. I'm going to say VLAN 999, and I'm going to name it parking lot. And this is the convention that I use, right? So now we've got this VLAN created called parking lot. Now, it doesn't look like it's in here because what I could do on a real Cisco switch is I can actually completely disable that. I could shut that VLAN down. So not only is the port going to be shut down, but the VLAN into which I place the ports is also shut down, non-operational, and that is what you really want. So again, we're just kind of enhancing this activity here. So you create this parking lot VLAN, right? And that is the VLAN into which we're going to put, so I'll say do show IP interface brief, and I'm going to trim this down for you here in a second. So, you know, the window's pretty tall, right? And if I was to stretch it out a little further, we can probably, right there, see all of the interfaces that are up and all of the interfaces that are down, right? So how can I trim this output down? Well, I can come over here and say include down. And so now I only get the unused ports, because any port that is up, right, even if it's up down, that could be a problem, but it means it's up. So these are all the ports, fast Ethernet 02 to 024 and then gig 02 that are down, that are not being used on the switch. So how do we, in one fell swoop, impact all of these? Well, we say interface range fast Ethernet 02 to 24. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I'm just double checking here, comma, gigabit Ethernet 02. So we do the interface range command. So now any command I type, like shutdown, is going to shut down every single one of the ports in that range that I just specified. Now, the other thing that you would want to do is say switch port mode access, switch port access VLAN 999. And now what we're doing here, if I say do show run, is we're making it so that it's not going to be an accident that a junior network admin comes into fast Ethernet 03 and decides to move it into a different VLAN and to bring the port up. That would be a deliberate, now they may mistakenly go into the wrong port, but coming into a port and then saying, well, I'm going to move it into a different VLAN and I'm also going to say no shut. That is an intentional act, right? That's something that, you know, you just don't mistakenly plug the cable in, or you say you mistakenly plug a cable into the wrong port. This is going to protect you, right? This is protecting you from plugging something in, possibly into the wrong VLAN that you don't want to, right? So we make it an access port so that it's not a trunk port, or it doesn't try to negotiate either, right? There's other settings that we could put on here. But at the least, this is what you would want to have, right? We put it in that parking lot VLAN, make it an access port, and shut it down. And then behind the scenes, we're also shutting down the VLAN. All right, so that takes care of that part, and you can see, oh, and they actually gave us the range right here. So, all right, so let's go ahead and see. So we're going to encrypt all plain text passwords, right? So let's get out of that interface range. So it's going to be service password encryption. Set a strong secret password of your choosing, right? So enable secret and we'll say ABC. And again, there is no, I'll show you that command from above on the security does not exist here. So I'll say ABC123. Let's see if we get any points for that. So yeah, it did give us a couple points, even though it's a pretty bad password. Now, what if I was to try to say security, security question mark? You see, it doesn't even recognize the command on the switch. And on more recent switch platforms, right, like real 9300s, 9200s, that command was not there, especially on 2960s, 3850s. Okay, so we set a strong password. Let's go ahead. And it wants us to do the IP domain name. Let's get that done. And we'll say ccna.com. And it needs to be caps for PT scoring. And we did get a few points there. No IP domain lookup. And let's go ahead and say crypto key generate RSA, and we're going to set it to 1024. So we've taken care of that. And let's configure the VTY lines for SSH access and use the local user profiles for authentication. So if I say do show run and section line VTY, you can see we've got 15 VTY lines here, and they want all, I'm sorry, 16, and they want all 16 of these, 0 through 15, to be set up for login local, right, to use that local login account, and I'm not telnet access, so I want transport input SSH for the authentication. So configure all VTY lines for SSH access and use the local user profiles for authentication. All right, set the exec mode timeout. So exec timeout is going to be 6 minutes on all VTY lines. And now finally, we're at 90%. We're going to save the configuration to NVRAM. So I'm assuming we're going to get 5 points for this. And they're probably not looking for write mem. They're probably looking for copy running config, startup config. Because again, we're saving the running config, which is what we've been manipulating on both the router and the switch this entire time. And so we want to make sure that if the switch gets turned off, powered off, crashes and comes back up, whatever the case may be, that it comes up and loads this config that we currently have running on the switch out of the startup config, right? It's going to load it up out of the startup config. So, yep, startup config, and we're good, and we only got 2 points for that. Let's save the, whoops, that's right. So it's locked here, so we're going to have to come back over to PCA, kill this, go to the terminal, open the terminal up, and here you can see we are consoled in again, right? ABC, oops, sorry, and we want to do copy running config, startup config here, and again, we don't get, or did we get? Yeah, we got 3 points for that, so we are at 95%. So we're missing something. It's probably something I read right by, and so let's go ahead and do a quick check results and see what it is I might have missed. The enable secret on router A and username on the switch 1. Huh. All right, so let's tackle these one at a time. So I was pretty sure, but again, I segued, keep forgetting. I want to go right to the CLI instead of through the router. So let's say show run include username. And so the username admin, and let me make sure that they didn't want us to use, yeah, any user, any password. Create a user of your choosing. And so then let me take a look at the show run include secret. Ah, I see. We went right by the enable password, didn't we? Actually, I don't see it asking for that. And again, I might be looking right by it. So let's just do this. We'll go into global config, and I'm going to say enable secret, and we'll just set it to ABCDE 1, 2, 3, 4, 5. And that should be, yeah, okay, so apparently it was asking for that. Again, if it's there, I'm just missing it. I see the username, but I don't see it asking for the enable password to be set. Okay, so it's there. All right, so that takes care of, and then we'll say copy running config to startup config. All right, so we're at 97%, and then on the switch, it was that we were missing totally skipped the user. All right, so username, admin, and we'll just say password ABC123, and that should take us. There we go. I apologize. I must have read right by that. It's tough, looking to the left and looking to the right. All right, so we'll say copy running config, startup config, and that is going to do it for this activity, Packet Tracer 26.2.4, where we took an in-depth look at configuring security not only on routers, but on Cisco switches. And it's always a good idea to make sure that you have some sort of a template that you're applying universally to your devices that's going to provide the same level of security, right? And to make sure that it's good security. And we also talked about the Type 9 and the Type 8 hashing algorithms, the script and the SHA-256 respectively. All right, well, that is it for activity. This is our penultimate activity, by the way, 26.2.4, configuring secure passwords and SSH. Thank you guys so much for watching. Let me know if you've got any questions, and I hope to see you in the next video.